to special factors now. So having special factors, this is the opposite of our product. So we're kind of like undoing what we did before. So we're going to factor using difference of squares, factor perfect square trinomials. We're going to eventually get to completing the square in the quadratic formula. But remember, perfect squares are, and if you're in my face-to-face class, we talked about this before. I never gave you a paper for it, but looking on perfect squares, 1 squared is 2. 1 squared is 1, sorry. 2 squared is 4. So the perfect squares are these numbers on the left-hand side there. Their square root is the number without the squared. So 16 is a perfect square. The square root of 16 is just 4. So those are the numbers you need to be aware of. 1 really doesn't count. So difference of squares. This is the formula you need. A squared minus b squared. So if you notice, that was one of our special products. So now we're going to do the opposite. This is going to be a minus b, a plus b. So you can write it as a plus b, a minus b. The order doesn't matter is what I'm trying to say here, but you're going to have 1 plus and 1 minus, the opposite signs. So we're working backwards. Remember, we started with a plus b, a minus b, and we got this product here. Now we're going to take this product and we're going to factor it backwards. So the 4 steps. Are there only 2 terms? Is the first term a perfect square? Is the last term a perfect square? Is there a subtraction in the problem? If all these are true, you can factor during this method. And you do have to do the GCF. You just want to check for that. I didn't include those. So looking at this problem, factor x squared minus 25. Go through those. Well, first of all, is there GCF? No. 2 terms? Is there 2 terms? Yes, there's 2 terms. X squared minus 25. Is the first one a perfect square? Yeah, the square root of x squared is x. Is the second one a perfect square? Well, 25, the square root of 25 is 5. Is there a subtraction sign? Yes. So you write your answer, x plus 5, x minus 5. There, you factored it. You're done. That's too easy, Miss Weatherall, I can hear you saying. Yes, it is. That's why I want you to know these formulas. So let's factor this one. Is there a GCF? 16 and 9. Nope. Is the first term a perfect square? Yes. Well, what is it? Square root of 16 is 4. Square root of x squared is x. Is the last term a perfect square? Yes. Square root of 9 is 3. Is there a subtraction sign? Yes. So you can take this and factor it to 4x plus 3, 4x minus 3. No way! Yes, it's so easy. All right, so try this one. Do you have a GCF? No. Is there 2 terms? Yes. Is the first one a perfect square? 9a, yes. Is the last one a perfect square? 7b, yes. Subtraction sign? Yes. So my answer, yep, you got it. 9a plus 7b, 9a minus 7b. It's that easy. All right, you try it. Factor this. You got it. You can pause the video because I'm going to keep going. That's it. You can also write it. Remember, the order doesn't matter as long as you have 1 plus and 1 minus. So I just wanted to reiterate that. All right, so now, is there GCF? Yes, 3. So we have to factor that out first. So then you go through the process. Ignore the 3. Is the first term a perfect square? The last term a perfect square? Subtraction. So you bring that 3 down at the end. You kind of ignore it for the process in the parentheses, the quantity, and you factor it to 5x plus 2, 5x minus 2 with the 3 out in front. Factor this one. Pause the video. You got it? I'll wait. Okay, start the video back. Hopefully you did. GCF, yes. Okay, they meet everything except subtraction, so that was a trick question. So the final answer is this. There's not a subtraction sign, so I have to leave it there. So I tried to trick you on purpose to make you aware not to make that same mistake again. Okay, remember, you can rewrite things if they look weird to you. So 4m squared is really 4m squared minus 64 there. So then it fits that term and you can factor it. Just going through these so you can get the idea. You can always pause this video and take a closer look if you need to. So to factor, express each term as a square of a monomial. Okay, so we've already talked about that. Let's see if there's anything else I need to. Oh yeah, what if there's fractions? Well, is 1/49th a perfect square? Yes, because the square root of 1 is 1. The square root of 49 is 7. So you can actually square the, factor this to 1/7 x plus 9, 1/7 x minus 9. So try these, pause the video, and then start it when you're ready. Hopefully you got those answers. All right. Now let's go on to perfect square trinomials. I'm going to make another video for that.